Hey guys, it's Mr. Dugal, and today I'm going to help you try to not be mad about mad. And to know how to not be mad about mad, we first got to realize what mad is, and mad stands for our mean absolute deviation. And what this means is it all revolves around our mean, and it's trying to measure the spread or the variability. So what we mean by that is how much the numbers differ from the center. So a group of numbers that has a wide range. So pretend we have the data group 1, 2, 5, 75, 99, and 102. Its mean is going to be, in the middle here, somewhere around 50. But it has a huge spread or variability. Most of the numbers are nowhere near 50, compared to a list like 49, 49, 49, 51, 51, 51. Okay, this again is going to have a mean of 50. It's going to actually be exactly 50 this time. But it's a much different data set. To just say the means are 50, say the means are 50 here, would give you the impression that both data sets are relatively similar, but they're not at all. The first data set has a large spread or variability. The second data set has hardly any spread or difference between its smallest number and its biggest number. And that's what MAD attempts to discover. So in order to find MAD, we first have to find the mean. So in order to find MAD, I'm going to just create a mini data set here, or a mini checklist here to help you remember this. So number one, we find mean. So when we add all these numbers up, we discover that the total of our data set, when we do 22 plus 26 plus 20 plus 24 plus 26 plus 27 plus 23, it should have us end at 168 as our total, and we divide by 7, because when we find mean, we do the total divided by the number of numbers. When we do that, we get exactly 24. So in this case, our mean is 24. Second thing we have to do is find the difference between the mean and each number. Now, I will tell you that I chose a very friendly total and a very friendly average here. It won't always end in a whole number, and we won't always have whole numbers from which we're subtracting. In this case we do, so it makes our job a little easier. The difference between, and when we find the difference, we got to find the absolute value difference. Meaning, even if I did 22 minus 24 and it gave me negative 2, I'm going to find the absolute value of that, which would just be 2. So here we have 24 minus 22 is 2. 26 minus 24 is 2. So that's a good example right there. If I looked at it one way, it might say negative 2, but I want the absolute value. So even if I get negative 2 as the output for one of them, it's going to be 2 either way. Here, 24 minus 20 is 4. 24 minus 24 is 0. That is the mean. 26 minus 24 is 2. 27 minus 24 is 3. 23 minus 24 is negative 1, but we're finding the absolute value, so it's 1. The final step is to find the mean again, but this time with the differences. So this time I'm going to add up all of the differences that I found, and again I'm going to divide by 7. I should be dividing by the number of numbers both times. In this case we have a total of 2 and 2, it makes 4. 4 plus 4 equals 8, plus 0 is still 8, plus 2 is 10, plus 3 is 13, plus 1 is 14. 14 divided by 7 is 2. Our MAD equals 2. What this means is that on average, the difference between our mean of 24 to each number on average is 2. Obviously, sometimes it's more than 2, sometimes it's less than 2. But on average, the difference between the mean and each number is 2. This would be a relatively low spread or variability compared to a data set like the one we highlighted down here, which would have a rather large MAD because the numbers are very far apart from one another. That's about it. Hopefully this helps us to understand how mean absolute deviation works. And we abbreviate that as MAD, and hopefully this helps us to not be mad about MAD. Thanks so much for listening.